we talk about like quadratic and talk about linear or like hyperbola or truncus, they have a particular shape. For example, all the quadratic looks like this or that. They have the same shape. But even though they have different, for example, quadratic got turning point form, x-intercept form, or general form. After we sketch it, they all look the same. But for cubic, it's a little bit different, and same as like quartic, it's a little bit different. So what's the difference? There are two forms. Okay, there are two forms, and the different form will give you different shape of the graph. Okay, different form will give you different shape of the graph. So for cubic, the first form we can have is called the point of inflection form. Okay, or can say stationary point of inflection form. So stationary point of inflection form, which you can see is really looks like quadratic. Okay, really looks like a quadratic. So the only difference is we change the cube square to cube. Okay, so turning point is h comma k. Remember, its turning point is h comma k. So the stationary point of inflection in this question will be h comma k. So will be h comma k. So which is this point. Can you see what's the difference between this graph and a cube root graph? Do you remember what the cube root graph looks like? You just did that in the test.
It's like way?
Yeah, it's more like the reflection way. So actually, this graph, if you reflect that by the line y equals to x, you will have the cube root graph. Okay, if this graph reflects by the line y equals to x, you will have the cube root graph. Therefore, I can say that this cubic, stationary point of inflection cubic, will be the inverse function of the cube root. Okay, they are inverse functions. They are inverse functions. And also you can see, this is more like a horizontal place. Can you see there's more horizontal, like the stationary point of inflection. But when you sketch cubic, I'll use a black color to sketch that. It's like a vertical place. Can you see in the middle? Like it's a vertical. Like they all call point of inflection, but one is horizontal, one is vertical. So that's the difference between the two shapes. They are all increasing function. Can you see they all increase? But one is increased very slowly, which is the cube root one, and the other one increased really fast. So they are inverse functions. I don't say they like all the this form is the inverse function of the cube root. So for example, y equals to x cubed will be the inverse function for y equals to cube root x. So this pair will be inverse functions. If you can sketch that, that's what I've shown here. So this is y equals to cube root x, and this one is y equals to x cubed. So they are inverse functions. Another thing is why I marked the paper yesterday. Some of you write the cube root, which is not the like good way to write it. Like the 3 needs to be a really small number on the left corner, like it should be on the corner, and then whatever you have inside, like that's the cube root 2. I see some of you answer like 3, like it really looks like a 3 square root 2. It's not a cube root 2. Just be careful with your notation. So the 3, like the 3 needs to be on the corner, and then that's the cube root. Yes?
Did you mark it down this time? If we get to
I think I didn't this time, but I have labeled it out. But you will lose mark if you did that in the VC exam, because I really can't see whether that's a cube root 2 or a 3 root 2. So there's not like there are two different numbers, that's two different values. So you need to be careful with that. Okay, so this is the first form. What kind of graph you have? The graph you have looks like this. Okay, it looks like this. There's another form. Well, this is the first one. And the second form is in this one. It's a it's in a factorized form. Okay, I will talk about that later. So the factorized form will get graph in this shape. Okay, it's like a turning shape. So that's if you have a factorized form for the cubic, so that is the kind of graph you have. It will look similar to this. So can you see that totally two different shapes for the cubic function? For like quadratic linear, they all look the same. Is that a linear or a parabola or like the two parabolas, hyperbolas, and truncus? They all look the same type. But for cubic function, different form will give you different graph. So let's have a look at the first one, which is the turning point, a stationary point of inflection form. So what we will have for this type is we will have stationary point of inflection at 0, 0. Well, we will have stationary point of inflection at h, 0. So that's what we will have. So stationary point of inflection will be at h, 0. And then we can see the domain and range, they're all R and R. If there's no restriction for cubic graph, there's no restriction on the domain. So we can take everything. And the range will be R as well. So that's for the cubic graph. Okay, how we can sketch for it? First of all, we make sure where is my stationary point of inflection, which is h, k. And we need to be aware of the form needs to look like x minus h cubed plus k. So the x needs to be a positive x. Okay, the x needs to be a positive x. So let's have a look. If the first example, we will have stationary point of inflection at 4, 2. That's really in the standard form. And we can see that directly. But for the second one, for this one, you can see my x is not a positive x. Okay, it's a negative x. So what we can do is we can rearrange it. So we say 3 times negative 1 times x plus 1. I will take negative 1 as a common factor and then cube that plus 3/2. We take a minus 1 as common factor in the bracket minus x minus 1. And then fx equals to 3 times minus 1 cubed times x plus 1 cubed plus 3/2. A times b cubed equals to a cubed times b cubed. So that's how I can make the negative 1 disappear from that bracket. And therefore we have negative 3 times x plus 1 cubed plus 3/2. So therefore I can see the stationary point of inflection at negative 1 and 3/2. Negative 1 and 3/2. So otherwise we will say, the point of inflection may be 1 and 3/2, but it's actually not 1. It will be minus 1. You take the negative out and you can see it. It must be in the standard form, and then we talk about what is the stationary point of inflection. So, yes? Yeah, you can, but like that's another thing I want to talk about. We need to think about whether it's an increasing graph or decreasing graph as well. So the minus will, well, you can still do it, but like it may be easier to just make everything into the standard form and then look at it. So the first one, we can do the same thing, like make things equals to 0. That's what we normally do when we sketch other graphs. So the first one is find the stationary point of inflection. And second one will be decide whether it's an increasing graph or decreasing graph. So if A is greater than 0, we have increasing. If A is less than 0, we have decreasing graph. But when we say this is we must have the standard form x minus h cubed plus k. If it's not in the standard form, we can't use A less than 0. Because if we see this question, A here is positive. Can you see A here is positive? But it's not the increasing function, because we rearrange it, we can see A is actually become negative. So we need to make it into the standard form first, and then look at the A value. So that's decreasing function, and the third one will be find xy intercept. There will definitely have xy intercept because domains are, ranges are. X can always be 0, y can always be 0. So we can always find x and y intercepts. This is when we have cubic graph in this form, okay, in the a bracket x minus hq plus k form. This form is not you find it, okay, you can't find it. That's when they give to you directly. They give to you, okay, the form. This is a cubic graph, it looks like this, and you sketch for it. You can't say give you a general equation and then you make it into the cube, into this form. It's not really possible for you now to do it. Yeah, yes. You can't complete the cube really because there's too much things to think about. You have like, for example, a plus b cube. You have a cube, b cube, and in the middle is 3a squared b, and then plus 3ab squared. Like, it's too much things to consider. You can maybe finally make it, but it's just too hard to do it. And it's plus, it's not all the cubic function can be made into this form. Very limited number of cubic function can be made into this form. So it's not really possible to do it. You can't test at the beginning whether it can be made or cannot made. We don't have the discriminant thing to talk about here. So we don't need to worry about to like complete the cubic to make into this form. This, if they want you to sketch it, this form will be given to you directly. Okay, it will be given to you directly. Any other questions? Okay, if you don't have questions, let's just sketch for this one. If you want to sketch for that, we have the stationary point of inflection already, and we can see that's an increasing graph, right? We can see that's an increasing graph because a is a positive number. And then we can find xy intercept. We can find xy intercept. Well, we have a really large y-intercept. Don't really want to find it. So we find f0, that's the x-intercept. f0 will equals to 2 times minus 4 cube plus 2. Well, really large. 2 times minus 16 minus 64 plus 2, and that's 2 times minus 63, that's minus 126. Well, that's the y-intercept, so really negative number. Factorize, take 2, you have negative 64 plus 1. Or you just calculate, it will give you negative 1 to 6. You will get that finally. Someone outside? And we find the x-intercept. We make that equals to 0. We have x minus 4 cubed equals to minus 1. What's cube root negative 1? Okay, so if cube root is negative 1, write negative 1. I have marked all your papers, and there's so many answers give me cube root negative 1. Just put this there. Like, you need to simplify it. That equals to negative 1. You need to give me negative 1. Okay, negative 1 times negative 1 times negative 1 give you negative 1. So cube root negative 1 is negative 1. So x minus 4 equals to negative 1. X equals to 3. We don't have plus minus here. It's not an even power. Okay, we don't have plus minus. It's not even power. Yes? Well, I just factorize it. I take the 2 out. Well, if you calculate, you have negative 126. So you get this value. I just factorize the 2. So 2 times negative 64 plus 1. Just take the 2. It's just quickly calculated. So you can just normally calculate. You have the same value. One thing is, well, when I mark the paper, one thing like is, for this number, like on the paper, it gives you the approximate value is 5/4, I think, or 4/5, like some value, give approximation value. That thing is help you to find where is that point. It's not ask you to label it as 5/4. Do you understand that? This is not equivalent to 5/4. It's approximately 5/4. So you know that's 1.25, and you can label it around 1.25. It's help you to make sure the location. I didn't take mark off this time for the graphing part, but the next question is ask you to find the range, exact value. I will take mark off if you put 5/4 there, because that's not exact value. Yes? Next week. And this number and -1, which one is larger? This value and -1, which is larger? -1 is larger. So therefore, when you write the interval notation, you're not going to write like this. Okay, so smaller number must be on the left hand side. Okay, smaller number needs to be on the left, and larger number on the right. Okay, so that's something. It's not only one or two of you get it wrong. So it's a lot of you get this question, like get this wrong. I don't know. I think maybe you're just too nervous and you can't see which one is smaller and you put on the wrong side. Yes? No, exact value is cube root 2. Cube root 2 is approximately 5/4. 5/4 is not exact value for that point. For that point is that. The 5/4 there is help you to find the location. Where is that point? Where is cube root 2? Alright, I need to come back to the teaching. Okay, let's sketch this graph. You'll see your paper next week. Stop, discuss that. Let's sketch for this. I need to finish up this. X and Y. Well, we have 4 and 2 is the stationary point of inflection, which is here. And then three, 0 is the x-intercept, and we know it's a positive shape. Well, I can't really sketch it beautiful because it's too negative, like it's a very steep graph. With stationary point of inflection at 4, 2 and 3, 0, and this point is 0, -1, 2, 6. Well, I can't draw it to scale, it's too negative. Any questions? Okay. Next one. Next one, we find the x-intercept. We find f0. F0 will be -3 plus 3/2. And that's -3/2. So we have 0 minus 3/2. And then we solve for the x-intercept. Okay, got half here, and x will be cube root over half minus 1. But we need to rationalize it. Well, what we have is a cube root 2. 1 minus 1. Think about it. We need to, like, that's a cube root 2. We need to times another 2 cube root 2 there, right? Cube root 2 times cube root 2. So denominator will become a 2. And then numerator is cube root 2 times cube root 2. Well, think about square root 2. We need to times another square root to get rid of the square root, right? Become a 2. So cube root is 3 things times together, give you the integer out. So cube root 2, that's one of it. We need to times another 2. So denominator is cube root 2 over 1, right? We need to times cube root 2 times cube root 2. And then the top needs to times cube root 2 times cube root 2. So denominator become 2. And the top left with cube root 2 times cube root 2. That's actually a cube root 4. You times them together, like square root. It's exactly the same calculation way as a square root. Well, square root a times square root b is square root a times b. So that's the number. Okay, that's the number. Well, it doesn't matter. Like, you can write y there. So you can see this is a decreasing graph because we have -3 here. That's a decreasing graph. So our graph should look like, you can see that's the graph. Looks like that. Oh, I can't really show, well, it's too tiny. Okay, it's here. This point is 0, -3 over 2. This point is -1 and 3 over 2. And there's an x-intercept, which is cube root 4 over 2 minus 1, 0. Okay, that's how we sketch a cubic graph with formula stationary point of inflection form. Okay, with that form, we will have graph looks like this. Okay, the two graph shows you here. The only difficulty might be the number is a little bit hard to calculate because it's a cube root, and we can't really take some values cube root, for example, cube root 2. But we can rationalize, we can times divide as the normal way. So it's exactly the same as a square root. Okay, as a square root. And what you need to remember is the inverse function of fx in this form, the inverse function will be a cube root function. You can find inverse for this form. You can find inverse for this form. Remember what's the requirement for inverse function? It must be a one-to-one function. Well, even though it's not a one-to-one, I can restrict the domain to make it become a one-to-one. Like quadratic, I can restrict the domain half or the other half. So to make it a one-to-one function. But this one is a one-to-one function already. Okay, it's just directly itself is a one-to-one function. Yes? It will, because the negative will get cancelled. That's how you get the -1 out, and then times -3. That become a 3, and then it will become a positive. So back to this one. So cube root function. So some question will ask you to sketch the cubic and the cube root function on the same set of x's. So they are inverse functions. All right, let's have a look at the next one. Okay, I have asked you to factorize these questions. I have asked you to factorize these questions yesterday on the next 2 pages. So I'm not going to show you how to factorize. I'll quickly do it. So I think most of you have done it already. Could we please stop talking? It's really hard to teach. Questions? So we still use this. Well, this is a general form for cubic. I'm not going to read through all of this. I'll just explain everything to you, and you can read it if you forget how to sketch. What we'll do, give us a general form. As I said, I'm not going to complete the cubic to make it into that form. It's too hard to do it. So, or some question can't even do it. So what I'll do is I'm trying to factorize it. So what kind of thing I can factorize? Well, if I can fully factorize it into 3 factors, I will do that. If I can't, well, I will show you when I can't. So what I will do is factorize, always factorize first. For cubic, you can at least got 1 factor. Okay, you can at least got 1 factor, and then leave it with a quadratic. So what I will do is put the coefficient 1 to -5 and -6. And what I'll do, I will try, well, I know -1 should be a solution. I try -1. What I can try is +-1, +-2, 3, 6, 2, 3, 6. 1, 2, 3, 6. So I try -1. I have 1, -1 plus 2, we have 1, -1 plus -5, we have -6, and that's a 0. So my fx looks like x plus 1, x squared plus x minus 6. And I can further factorize it as x plus 3 and x minus 2. That's how we can factorize the quadratic. Well, I can see the cross multiplication. I can fully factorize it. So what I can say now, fx is in the fully factorized form. Okay, it's in the fully factorized form. So if you have done it, you should have the exactly same thing here. So next thing what I will do is I will sketch all the xy intercept. Why I factorize it? Because I want to see all the xy intercept. What's the y-intercept? 6. 6? -6. Okay, -6. So, make it. How we can see -6? We can see that from the very original equation, like the fx equals to there, and the constant will be the y-intercept, which is -6. Okay, the -6 is here. Okay, can you tell me what's the x-intercept, please? -1, -3, and 2. Let's label that. 2, -1, and -3. So I will label as this. Okay, I'll label as this. And the next thing is the fun step. So I need to go through all of these holes. Okay, it's like you doing the sewing thing. Okay, go into every hole and then come in and out. Where I will start? I will always start on the right hand side. Okay, always start on the most right hand side. There's a top part and bottom part. So the x-axis is like a piece of cloth. You either start from the bottom like this, or you start from the top like this. So where to start with is depends on the leading term. Do you have a positive leading term or negative leading term? Positive leading term. That's why we'll start from the top. Okay, we'll start from the top. If you have a negative leading term, we'll start from the bottom. So now we start from the top. So let's think about there's 3 holes here, and then we start from top. We need to go into every hole. So what it looks like, it will be go into that one, well, turn and turn. Well, it's not really straight. Maybe it looks, make it a little bit better after you sketch it. Well, something like this. Okay, something like this. Yes? No, we'll need to do that in term 3, but not now. Like, we'll learn other things. We can't find turning point. But what you need to remember is turning point is not in the middle. Turning point is not in the middle of the 2 points. We don't know where is it. Also, you don't show your turning point on the y-intercept. Can you see I put the turning point here instead of putting on the y-intercept? Well, it might be on the y-intercept. I don't know. I have no information about turning point. Even not one piece of information. What I know is normally it's not necessary exist in the middle of the 2x-intercept. So it's not in the middle. Well, we have what's that point? That's 2, 0. So that's minus 1, 0. And that's minus 3, 0. And then we have 0, negative 6. This turning point and this turning point is not negative 2 and half. Like, I don't know where is it. It can be 0.8. It can be like, that one can be negative 2 even. So it's not in the middle. So we will learn that when we learn differentiation, which is like the differentiation calculus chapter, which is term 3. I think term 3 will learn that. But now what you need to show is just a graph, and don't show you turning point right in the middle. Just maybe a little bit left or right. So we have no information about that. That's how we complete this graph. Okay, that's how we complete this graph. Okay, quickly go to the next one. I must finish this today, otherwise you can't do that on the digital deliver day. For repeated factors, okay, repeated factors. Well, I don't know whether it's repeated factors or not yet. So what we will do is still factorize it. What I should write in this box. So 1, 2, 3, 4. Yeah, what I should have. What's the first one? 1, 0, negative 3, and negative 2. We must have the 0 there. If you don't have the 0, you can't factorize it. Well, I think negative 1 should work as well. I put 1, that's a negative 1, that's a negative 2, and that's a 0. This one works. So fx equals to x plus 1, x squared minus x minus 2. So fx equals to x plus 1, x minus 2, and then you have another x plus 1. This is called the repeated factor because you have x plus 1 twice. X plus 1 squared and then x minus 2. Now we do the same thing. Okay, where's the x-intercept? Negative 1 and 2. Okay, what's the y-intercept? Negative 2 here, so that's the y-intercept. The constant is the y-intercept. So we have 0, negative 2. Okay, which factor is repeated? Negative 1 is repeated. Okay, if negative 1 is repeated twice or 4 times or 6 times, even number of times, that will become a turning point. So let's label a turning point here. So this point will actually become a turning point when you sketch it. So think about, there's a hole. So we start from here. We go through the first one, and then we're trying to hit that one. But this one become a turning point. So when we hit it, we'll suddenly turn back. Okay, so we start from here. Go first one and second one, and we'll turn as a turning point. So So that's how we sketch it. Oh, this is even number of times. Yes, to become a turning point. Odd number of times, I'll show you later. That will become a stationary point of inflection. If it's repeated 3 times or 5 times or 7 times, like the odd number of times. So even number of times becomes a turning point. Odd number of times becomes a stationary point of inflection. Repeated. So I will go through positive leading term. See positive leading term here. So what I will have is go through the first one, turns to the make it smaller. Well, I can't sketch it. Okay, hit that point, but become a turning point. So touch. So it touched the x-axis. Can you see it touched the x-axis? I'll show you how to repeat 3 times later. If it's repeat 3 times, I'll show you what it looks like. Let's compare this graph and the above graph. Okay. Can you see even this one got only 2 x-intercept, but you still have the same shape? Can you see that? There's still the same shape, like this. Well, the negative one looks like this. Positive one looks like this. Wait, this positive, and then the negative one looks like this. That's the positive. That's negative. But let's have a look at the next one. If we factorize the next one, okay, we have -1, -3, -1, and 5. Okay, we try a number. Okay, we try a number. Let's try just one. We put -1, -4, -5, and 0. That's what we have. So my fx equals to x minus 1 minus x squared minus 4x minus 5. Well, it's a little bit annoying. I put negative out. Negative x minus 1, x squared plus 4x plus 5. Can I keep factorize it? No, because discriminant equals to 4 squared minus 4 times 1 times 5. That's less than 0. Discriminant less than 0. So if that's less than 0, can't factorize, which means I don't have other factors. Therefore, how many x-intercept you have? Only one, right? Only one. So let's label this graph. Let's put this information on the graph. So what's the x-intercept? 1. So y-intercept is 5 and x-intercept is 1. Do we start from positive or do we start from negative? Negative. Okay, what a negative cubic looks like? Looks like this. Okay, looks like this. See, this graph looks like this. Start from negative and go through the first intercept and go through there. Wait, let's draw like this. But you must turn somewhere here. Okay, can you see? You must turn. You want to keep the shape, but at the same time, I only have one x-intercept, so you can't go like this. Can't go down and then cut the x-axis. So you must turn. You still have the same shape, and you want to satisfy there's only one x-intercept. Can you see? You will turn somewhere in the middle, in the air. Okay, not touch the x-axis at all. Yeah. It can on the right hand side. Okay, it will be squished, like it will squish. So you can draw either side. But you can see how ugly the graph will look like if you put on the right hand side.
Okay, but
yeah, it's right. I can say it's right. Like when we don't learn differentiation, we can say that's right.
Okay, cool.
Because we don't know.
Okay.
but the shape must be like this. And it must not touching any x-intercept. Yeah? So that's how this graph looks like. Well, where's that turning point and the top turning point? I don't know. Like as Sarah said, the positive one can squish onto the right hand side as well. And then you can leave the bottom one on the left hand side. That's all good. Okay, that's all good. But the only thing you need to achieve is you don't have any other x-intercept. There's only one x-intercept. And it must be a negative shape. So the negative shape looks like that. So that's the way we can sketch for it. That's when you get some quadratic cannot be factorized. That's what you need to do. Okay, some quadratic you cannot factorize. You only have one x-intercept. That's the shape of graph you have. Okay, one last thing is the inequality. Well, you can guess what we do for inequality. I said already at the beginning of the term, when you solve inequality which is not a linear, what do you need to do? Remember? No? Quadratic. What do you solve for quadratic inequality? How? How you solve quadratic inequality? Graph. Okay, that's the word. Graph. We graph it. We need to graph it. So let's graph the left hand side. So left hand side wants to be less than 0 or equals to 0. We need to graph the left hand side. Okay, graph the x cubed plus x squared minus 5x plus 3. We need to factorize it as well. So we can put a 1 there. 1, 3, 1, 2. Negative 3 and 0. So what we have is x minus 1, x squared plus 2x minus 3. We have x minus 1 and x plus 3 for this one to factorize. What I have here is x minus 1 squared times x plus 3. Okay, because it's a positive shape, we have turning point here. 1, 0 is the turning point. So we start from right. Turn here. Okay, we see that's how the graph looks like. That's how the graph looks like. What do I need is this thing less than or equals to 0. Okay, less than or equals to 0. So which part is less than 0? Here. Here. Including that point. Is there any other point satisfied? Less than or equals to 0. So 1 will be satisfied as well. Okay, 1 will be satisfied as well. So it's all this x plus this x here is the thing below or equals to 0. What I can write is x belongs to negative infinity and to negative 3 inclusive union a 1 in the curly bracket. Okay, in the curly bracket. That's how you solve inequality. There's no way you can see it from the equation. You must sketch for it and then see which part I want. And then what's the corresponding x. This is the only way we solve inequality which is not linear, by sketching it. Okay, by sketching it.